What's going on, you guys? My name's Kirby Downey and welcome to another awesome SolidWorks video where I'll be showing you how you can use SolidWorks and 3D printing to create something awesome like this crane. Let me just get this out of my face. So this crane has been entirely 3D printed other than the motors and the bolts that hold it together. There is no glue used in this. Everything is held together with bolts and the actual internal structure that makes it work. The idea of this project is to undertake a engineering marvel, which are cranes. Absolutely incredible machines, what they can do, how they're built, how they're assembled, how they're used every day. Everyone knows what a crane is, everybody sees them, but undertaking in a project of building my own crane, I learned a lot more about cranes, how they work, how they're assembled, and the engineering and mathematics that go behind building one of these, and they're incredible. Everything on this has been 3D printed. The Arduino has been coded by myself. So I learned a lot about coding in this project as well. So undergoing a huge project like this, I've learned how to code motors, I've learned how to code buttons, and I've learned a bit of engineering and how forces interact with each other. And I learned a lot about the 3D printing material and that as a medium. Because doing this out of steel, I could have done a lot more smaller bits, but obviously with plastic, a lot more thinking has to go into it. So it's got three functions. It rotates, it lifts, and the dolly goes back and forth. Let me rotate it back. It's a little bit slow. Again, before going into this, I had no clue about coding and I had no clue how to work with motors. Everything you hear is my first try. And that's been an incredible learning experience. Projects like these teach you a lot. So in this tutorial, I'll be going through the process I went to designing this, talk a little bit about the code that I created, show you some of the learning curves that I had to do and some of the changes I had to make while learning how to do this. So this is the code that was written in Arduino. A lot of it was hacked together from different source codes from the Adafruit stepper motor libraries and the Adafruit motor shield libraries. So to start off quickly, start off by including the wire H. Don't know what that does. Apparently you got to put it in there. I think it's just to include the Arduino. This one you got to include the Adafruit motor shield H. That's including all the information about the motor shield that runs all the motors. Here I've got to assign where each motor shield is. Because I'm using two, I've got to assign one as top and one as bottom, as well as a IP address kind of thing. I've then got to assign motors to the specific shields because I can only put two motors per shield. Motor 2 and 3 was put on the top shield and motor 1 is the bottom shield. Each with 100 steps and then giving them a number. I then assign each one of the buttons to a port on the Arduino board from 4 to 9. And then name them button 1 to 6. I then had to assign that each one of these buttons will initiate an input. And then I had to start the motor program. Start off each shield, basically telling them to turn on. I then had to set the speed for each motor. 10 RPM for motor 1, that's the one that rotates. Motor 2 was the one that moves the carriage up and down the boom, and motor 3 was the one that rotates the wire up and down. So this is basically, that's setting everything up. This is actually telling it what to do. So here basically I'm saying it that if button 1 is pressed, motor 1 will move per step, will move 2 steps in a backwards direction using double steps. Basically we use twice as much power. Or then if button 2 is pressed, motor 1 will step 2 steps the opposite direction, in a forward direction. Same thing for button 3, button 4, they'll drive motor 2 backwards and forwards, 5 steps per press. And then if button 6 and button 5 are pressed, motor 3 will move 1 step backwards and forwards. And that's the code. Very, very simple coding, the only thing that's tricky is you don't know how to put it in the correct language. So using the Adafruit forums, basically saying that I want button 1 to do A and I want button 2 to do C. And they basically helped me to put it in the correct language. So using that forum helped out a lot. So having this code beforehand and having all the motors, putting it together to make sure it works, helped out a lot before the actual build, and this was the starting point. From there, I jumped into SolidWorks to build it. So, jumping into SolidWorks, I started off by creating a little mock of the motor, just a model that I can move around and design around. From there, I created the first frame, kind of started figuring out the segments that I wanted to create and how I'm going to join them together using bolts to assemble it all. A lot of figuring out was going on here. I then decided to put the motor at a 45-degree angle, just so that I can actually screw it into place. I then started creating the top mount and started creating actually how it's going to rotate. Set my heart afire. A lot of this design process was actually figuring it out as I go. Try something out, see if it will work. If it doesn't, make the changes needed. Most of the features that we used in this entire build were extrude bosses, extrude cuts, revolve bosses, revolve cuts, and using patterns and fillets just to shape it up. Everything was just basic SolidWorks design. I then created the little buttons, created little plates to test if all the fittings. I then created the flip switch that I was going to use. I then started to plot out the position for the Arduino and the prototype board and create the actual box. I didn't want to spend too much time on this box because the main feature is the actual crane, so I just created a basic box that would hold the buttons and hold the electronics. It could have been much shorter, but I decided just to make it functional over pretty. Went off to print it all on my Prusa MK2S using a yellow PLA. So to assemble them together, I left these holes, but to make sure that there weren't any sagging, I left a little flat plate which I drilled out. I then placed the little bolts into the recesses that I created for them. Inserted the screw and used an Allen key to very gently screw it together. This took a lot of time to put together, so I won't show you it all. This is the motor mounting, so I placed the motor in there. I used a very long screw just to kind of hold it in place so that it's loose, and then I put smaller screws in that would actually hold it tight, removed the longer screws and then fastened it. I did end up removing this motor and putting it somewhere else due to the problem where the motor wasn't driving enough power to actually rotate it. So this is about 3 kilograms of lead, little lead pellets. I'll basically use these to weight down the actual base. So this took quite a bit of time, using a little spoon, trying not to get it in the center, as that's where the motor's going. So I just got to do them one section at a time till they're mostly filled up. Once I got them all filled up and the center part was empty, I placed the motor in there. Again, because I moved the motor into a different position, I ended up filling the entire thing with lead, which was good. To attach the weighted base to the actual base of the crane, I inserted these little bolts into these slots and then used a little screw to screw it into place. Very, very simple way of putting it together, and I think it matches the whole theme of the whole thing of mechanical nuts and bolts holding it together instead of glue. I use this little springy joiner I use on 3D printers to join the threaded bolts and the motors. So I attached it to one end to the metal rod, the other end was attached to the motor. I use these little grub screws to tighten it up and hold in place. I had a bearing that was about midway, so attached that all together again. Then I attached the top of the crane. I needed a second hand to help out here and just hold it balanced. I then inserted my little pin that I created. Very annoying to get screwed together, but eventually I got it right. Then I had to add a few more screws. Once those are all screwed together, it held it tight. I then inserted the little threaded rod. It's attached a similar way as the bottom motor. I just had to screw it in a little bit. So it popped out at the end, and then I could actually fasten it in place. I then used some fishing wire to go over the top just to give a bit of support throughout the entire thing so it can just feel a bit more stable. Clipping in these arcade buttons are great. They just have such an amazing sound to it. Click, and you know they're in place. There's something so pleasing about the tappiness from those buttons. Now it was time to solder all of the power supplies and all the buttons and put everything electronically together. So inside there was a very big hot mess of wires, which you don't need to worry about. So rotating this thing from the center didn't work, so I needed to move the motor and put it on the side with some gears. Basically, this problem could have been solved with electronics, maybe a bit of software, but I decided to engineer the problem. There's always more than one way to solve a problem. I just love to use engineering to solve the problem. So the idea here is that the motor will drive a gear attached to another gear that's attached to the actual crane, and then the motor spinning will then drive that gear, which will then turn itself around. The two gears that I created were basically the same ratio, which didn't work out as well as I'd hoped. I realized then I needed to make the driving gear smaller and the other gear much bigger. This will allow for less force required to move. So the end result was a bigger gear on the body and a smaller gear on the motor, and it meant it worked. Next was a little bit of cable management. Connecting it all up and then powering it on. Now there are various different ways to actually speed up this entire process. Using different code, using different, more powerful motors. I was just happy with the way that it turned out, considering it's my first time coding and putting these kind of things together. So that is the one motor that drives the carriage up and down the boom. It's the one that needs to be sped up a little bit. As you can see, it's very slow. These are the gears that drive the rotation of the entire thing. And then this is the motor that drives the hook up and down. So I hope you enjoyed that and you learned a lot from it. I definitely learned a lot from this, and I would really encourage you guys to set a goal, set a target, something you want to build, and then do it. Use SolidWorks to design it, to test it, figure it out. Use 3D printing to make quick iteration. I had to print out a few of these to test out if my printer could print it, if everything works out fine, before I came up with my final design and then moved on to the rest. I've been working on this for 6 months. And it's been fun, and I've learned so much about it. So having access to tools like Arduino, which is completely open source programming boards, and other add-ons such as the motors, the buttons, and LED lights, and there's just so much you can add onto an Arduino board, and it's all open source. It's all stuff that is community shared, and you learn from it. You learn from each other, and people help you out. You know, having Arduinos, having 3D printing, again, it's a community that is built on learning from each other. Having that to help figure out how I'm going to print certain things and how I'm going to go about it. And then SolidWorks, who has also an incredible community. If you're stuck on how to create something, or if you're stuck on you don't know how you're going to create a shape, the community is there to help you out. All of these technologies come together through community, and that is the most beautiful, and that's the most beautiful way of learning, is through community and through others. Don't be afraid to share your ideas. Show it to other people, learn from them, teach other people, inspire each other. See you guys in the next one. Yay, victory!